Okay, here is the next example in section 1.5. This section is called equations of lines. We're going to look at another way of getting an equation of a line using that idea of the coordinate formula for slope from before. So yeah, the one where the slope is y2 minus y1 over x2 minus x1. We're going to think about that, and we're going to use that to get a new way of getting an equation of a line called point-slope form. So let's first try this problem where we're just going to graph a line. I encourage you to try part A by yourself. Part B is probably tricky, but if you can do it yourself, go for it. But after you're done trying, and let's do it together now, after you have paused it and unpaused it. So we know it wants to have the point 1, negative 4 right here, and it's going to have slope negative 2/3. So that means when we have negative 2/3, that should be delta y over delta x. So you could use this to get another point on the line where there's some other xy point somewhere where the delta y is negative 2 and the delta x could be 3. So if the delta x is 3, we're going to go over 1, 2, 3. And then if the delta y is negative 2, we're going to go down here. So that was a distance of, I went a distance of 3 horizontally and a distance of 2 vertically. Negative 2, excuse me, because we went downwards. So those 2 points are enough to get you a straight line. You could also go backwards because, of course, there's a lot of equivalent ways to write this fraction. We could write it as positive 2 over negative 3 is the same number. You could write it as negative 0.667 over 1 if you want to see how much does y change if x increases by 1. Or you could write it in all kinds of other ways, like, I don't know, 4 over negative 6 is the same thing. So if it's 4 over negative 6, that would mean we're going to go backwards 6 this way. 1, 2, 3, 4, 5, 6. We don't quite have enough room to get over here to negative 5, but it's going to be about there. So that was from negative 1 backwards to so positive 1 for x backwards to negative 5 is a delta x of negative 6. And if the delta y is 4, that means go up from here. So we're going to go up 4. From negative 4, that will take you up to 0. So you could also get that point. Anyways, when you draw a line through it, it should look like this. And that's the line. So that part, you could hopefully do kind of a little bit of it by yourself, but finding an equation for it might be weird. So let's think about what we know about this line. We want to get an equation that is true for all of the xy points, like this one here, or this one here, or this one here, or all the other points on the line anywhere. And we can think of the line as the set of all points that you can get to by doing a delta y over delta x that has that same slope, so that where it comes out to a fraction of negative 2 over 3. So I just wrote that out here so you can see it written down. The line is the set of all xy points that make a slope of negative 2/3 with 1, 4. So how can you take that as an equation? I'm going to write down the statement that should be true here for all of these points. Here, I just wrote a sentence that should describe all of the xy points on the line. it should be the points so that the slope from xy to 1, -4 is -2/3. So I wrote the formula for the coordinate formula for slope here. Let's do this with the xy standing in for x2, y2. And to get the delta y, we're going to do that y minus y1, which is going to be this one. And we have x minus 1. That result, the slope from xy to 1, -4, must be equal to -2/3. So this is actually an equation that should describe all the points on the line. So if the question says find the equation of the line, I guess you could leave it here. It's not the nicest looking one, and I apparently can't properly draw a box. There we go. It's not the nicest looking equation because it has this x minus 1 in the denominator. So maybe let's try to write it in slope-intercept form. We want it to look like y equals mx plus b, but we need to get the y by itself. So the way to start that happening is to get the x minus 1 out of the denominator. The best way to clear denominators from fractions is to multiply both sides by that denominator, like so. So that will make the dividing by x minus 1 and multiplying by x minus 1 cancel each other out, which will leave you with just the numerator here. And on the other side, we'll distribute the -2/3 into that in just a moment. For right now, let's just leave it there because I want to keep this here for reference. But then let's actually go ahead and distribute that in the next step here. So that'll be -2/3 x. And -2/3 times -1 is just going to be +2/3. And this is another equation for the line, and the y minus -4 we should write as y plus 4, and then we can subtract that from both sides. And we'll get the equation of the line is y equals -2/3 x. 2/3 minus 4 is -10/3, I believe. So this is now in slope-intercept form. So this is the same line as we had before. But just written in the usual form. Okay, now actually what I want to do now is see what would happen if we had a different slope and we had a different point and we wanted to do the same thing. We could actually go through the same process no matter what the slope is and no matter what the other point that you're given is. But you don't have to actually show all of these steps. So what I want to do is I want to take the same argument, the same derivation here, and do it again, but we're going to do it again in an abstract way. I'll show you what I mean by that here. So let's talk about how to get the equation of a line with slope m and point x1, y1. But I left the original thing here because we're going to just see how it all works exactly the same way if we just replace the 1, -4 with x1, y1. So everywhere I see a 1, that's really x1. And the -4 is now going to become y1. And instead of having the slope be -2/3, it could be any numbers, and that's just what we're calling m. So this is an equation of the line. But we're not actually going to write it in slope-intercept form, so I'm going to delete that. We're going to write it in something sort of similar. Now, if we keep going on, replacing all of the specific numbers here, like so, I've replaced all of the negative 2/3 with just the symbol m, which stands for whatever the slope of this line is, and all of the negative 4s with y1, and all of the number 1 with x1, because that could be any old number. Then we can get these different ways of writing this equation. And this one right here is what is actually known as the point-slope form of a line. Maybe you don't want the parentheses quite so big there when it's just m and not 2/3, but that is point-slope form. It's an important one to know. It comes up every day in your Calculus 1 class if you're going on to calculus, and you're going to need to know it for this class. And in the next video, we'll do an example of one, of using point-slope form.